Hello, my name is Ben Holsworth, and this is my Project 2 for Georgia Tech's Fall 2024 Design and Manufacturing course with Dr. Hassan Rashidi. My project is a laptop charger cable management system. The problem. Cable management is a constant hassle in the modern age, especially for engineers. Cables can get wrapped around table and human legs alike, and wires get tangled with themselves and each other. In an age where the use of laptops, cell phones, and other personal electronics with chargers attached is so common, this problem is widespread. It's most apparent for me in my laptop charger, a heavy, unwieldy brick with long cables on both sides that constantly gets in the way of using my laptop. Trying to charge my laptop becomes an extended endeavor, and using it while charging is a complete hassle. This frustration has led me to a simple solution. The solution: by attaching several loops to the top and side of the charger block, the cables can be spooled around the block so that only the currently needed length of wire is free. By reducing the amount of loose cable, the impact on my workspace will be greatly diminished. There will be a set of loops for each cable, DC and AC, on the top and side of the block respectively. These additions will greatly improve the ergonomics of the charger and make using my laptop while charging it much easier. Here's a demonstration on how this addition can help improve the product. Without cable management, the charger cable is free to get tangled up on pretty much anything in the area, including other cables, and is in the way of working with other things near the laptop. However, with the addition of clasps on the top of the case, the DC cable could be spooled up on the top, and with loops on the side of the case, the AC cable could be spooled on the side. And this would greatly reduce the interference of the cables with other objects. If you imagine the cable spooled up on the side of this, and this cable spooled just the length that you need on the top, it would greatly improve the usability of the cable while using the laptop. So here are some concept images of the parts. So these images show the parts on a real size charger block. So the trapezoidal hole on the right is the DC power cable entry port, and the small circle on the left is the AC cable exit. So, as such, the AC cable loops, as you can see, will be on the side of the block in the direction that the AC cable will run. This will make it easier to spool the AC cable around them. And the AC cable is also fairly thin but longer, so more spools will be needed, but they'll take up less space on the loops, so that's why these ones are thinner. Compared to the DC cable loops, which can be seen on the right, they'll be on the top of the block. These ones will be a little wider and thicker because the DC cable is much thicker than the AC cable, but it is also a good bit shorter. So it will not have to be spooled as many times. It'll just need more space, hence why they're on the top block. This all can be seen in the CAD model here. So the DC cable will come out of this port on the bottom left and loop around the top two flanges, and then the AC cable will come out to the left on the other side of the block and can be spooled around these thinner spools or loops. And when completely spooled up, it should be much more portable and ergonomic. Manufacturing processes and materials. The attachments will be manufactured using injection molding, as their small scale and complex shape would make this the ideal process. The loops would need to be thin and curved as well as flexible in order to function properly. As such, the parts should ideally be made of thermoplastic material, as this would allow them the flexibility to bend slightly as the cables are looped around them, and reduce the risk of being snapped off on accident as they are firmly attached to the block. This makes them even better suited to injection molding since it's a plastic process. In addition, the parts should be fixed to the charger with a plastic-to-plastic epoxy treatment. Advantages. The advantages to this modification are clear. The improvement in ergonomics will make operating the laptop while charging, a very common scenario, immensely easier. By having only the necessary length of cable free, it will be much less likely to tangle or wrap around things. In addition, the ability to completely spool up the cables will greatly improve the portability of the charger, as it will take up much less space. This is another major hassle with dealing with chargers of this type, as the unwieldy block plus the cables makes it very difficult to store. All of this will be accomplished with minimal additional parts and only a small change to the profile of the charger block, thus only slightly increasing its size. Disadvantages. There are some definite disadvantages to this concept. While using the clasps properly will result in better cable management, i.e. by looping the cables around properly and storing it properly, neglecting to do so could cause worse tangling. If someone doesn't properly spool their cables or neglects to use the um, loops completely, then they could get tangled up around the loops or around other cables as usual. The loops could also snag on other cables or clothes if not used properly. Essentially, while the ergonomics of this product would be improved, the ease of use will be diminished. In addition, they will obviously require new manufacturing lines in order to be produced, increasing the cost of production. Molds will need to be made, and plastic curing locations will need to be created. Resources used in this presentation was the Manufacturing Processes for Engineering Materials textbook by Serapik Kapakajan and Stephen R. Schmidt. Thank you for listening.